So Austin, what are we going to be talking about today in this video?
Today we're going to be talking about new information we're going to be adding to our future sound testing videos.
Can you speak to why you selected the sound recording hardware that you did? Because I think people have seen analog meter and everything like that. So can you talk about that, the history of that?
Well, the 2209s were seen as pretty much the hardware to be using. We see back in military documentation back to 1977 that 2209s were in use. In a Small Arms Review article, Reed Knight talked about Don Walsh and also Mickey Finn using the 2209s. At that time, Mickey Finn's Qualitech, their lead engineer was Doug Olson, and Doug Olson had worked for Crane in the 60s. And so no doubt the 2209 came from the military.
And who manufactures the 2209?
A company called Brüel Kjær that currently is Hottinger Brüel Kjær, HBK.
And where are they from, and what makes them bona fide? Why is that the hardware that people have been using?
They're a European metrology company that essentially has foundational roots in, I believe, the 1930s or 40s. And they're considered a premier metrology expert, and their equipment is in use by companies like Boeing, NASA, obviously the military. They've had sound level meters in space on the space shuttle missions.
So they're kind of for lack of a better word, the Rolex of sound testing equipment.
I would say so.
Okay. So you were using the 2209 analog meters for a long time, which was pretty normal and standard for back in the day. When did you switch to the newer digital equipment, the Pulse system?
The Pulse system, I want to say, was state-of-the-art around the 2006-07 timeframe, but we did not switch that equipment till more like 2018, I want to say.
Okay, and I guess why did you feel like you needed to switch, and what new advantages did the Pulse system offer you?
Well, the 2209 meters were kind of becoming a little bit aged, and a lot of 2209 meters in use were not properly performing. We had 2209s that were still performing excellently, but there were things, capacitors and parts in 2209s that get damaged if you leave the batteries in the unit over time. And so the 2209's reputation was beginning to be harmed by the presence of so many, broken or defective or not properly functional 2209s in industry. And it was obvious that the analyzer and the multiple microphone testing was going to speed R&D.
So you acquired the Pulse system, and that allowed you to do what that you couldn't do with the 2209?
We could sample from 3 microphones simultaneously. We could also meter noises faster because the 262 kilohertz sampling rate is something on the order of 3 or more times faster than the 2209, which up to around that 2006 time frame, that analog equipment was the fastest equipment in the world. So we're talking very, very fast speed of data acquisition, especially that capture the peak for sound metering.
Can you talk about the history of peak decibel data and why that's the standard and still is to this day?
Okay, so for some reference, in about the 1950s and 60s, the Army began to be very conscious of the fact that a lot of people were getting their hearing damaged. And in the 60s, 1960s, there was still a belief that 100 rounds a day was a safe exposure level for a person to be exposed to. And very shortly thereafter, the Human Engineering Laboratory began to do more study, and they published 1472, Mill Standard 1472. And around that time, you could see the XM177 was being peak decibel tested, as well as with silencer principles and evaluation, in a military report, they were using the B&K 4136 microphones and doing peak testing of all the silencers that were relevant to military history at the time. That peak testing has been something that was carried forward with in the 80s, as I spoke about, Qualitech, Knight's Armament, as well as Don Walsh's Interand, and OpSync used the peak level testing. Surefire, AAC, all the companies to the present time have used the peak level testing. The relevance of peak level testing is that when a impulse noise occurs, the loudest moment in that peak impulse is a very sharp peak, and you need a very rapid rise meter to capture the top of the peak and not clip the peak. And that highest level noise is the most dangerous part of the overall sound composition, and that's why it was always relevant and remains relevant. And all this testing has been done in the A-weighting regime, in the Army and in the industry, because that is the human auditory loudness curve, and that tells us how we're going to be hearing the silencer as human beings.
Can you talk about when you acquired the B&K Pulse system? Did you set that up? Did you program it? How did that work out?
No, we came to B&K with a request. Of course, it's a sales situation, and we wanted to be able to do the testing like Silencer Co. was doing on their videos, and they were showing, I believe, a lab view, 102 kilohertz sound testing setup, so slower than the Pulse by a significant margin, but delivering the data digitally in real time in some kind of computer display without the use of manual input button presses. And that was significant because the 2209 at the time required something like 4 or 5 mouse clicks per round fired. So that was a significant challenge for B&K, and they had a sales technician and an acoustical scientist on the project for something like 6 weeks.
With Griffin?
Yeah, with us, and several visits to the facility, and having significant trouble getting this working, but they're a company that succeeds in applications, and they were able to put the template together, and we were able to compare the sound meter to the 2209 and confirm that the sound meter was working in a manner that was obviously correct.
Okay, so we know that peak data is important. We know that the history has shown us that it is important, and that a lot of companies have been interested in just peak data up to the present day. I guess what makes you interested in coming out with more data to show customers?
We're seeing on the internet and in interactions with customer service that people are more interested than they used to be in overall noise dosing information, and also graphical representations of sound pressure waveforms. And we communicated with Brüel Kjær, and one of the things they suggested was the use of the Army Research Lab's developed Auditory Hazard Assessment Algorithm for humans. And this project for the Army involved teams of scientists and peer review, and the use of a comparison of noise exposure to human and animal studies conducted earlier in history in the 60s and 70s, I believe. And they did some more animal testing, and also had the model tweaked a couple of times, and that standard has been, according to them, stable since the 90s. They've added the use of hearing protection devices, but that isn't quite as relevant to what we're going to be doing, which is showing the warned unprotected human ear risk levels with the system. And that system predicts with 95% accuracy whether a sound will produce hearing damage to a warned subject. It also suggests safe levels for every 24 hours, as well as safe levels per week. And they do that with auditory risk units, ARUs, and those levels are 200 ARUs are considered permissible every 24 hours, and 500 ARU exposures require a 1-week recovery period.
So essentially, you said you wanted to provide more data like waveforms and graphical analysis, and B&K suggested that you talk to or research the U.S. Army Development Command Army Research Laboratories testing. Is that correct?
Yeah, and that seems very sensible and logical, since those people have been working for approximately 33 years on this subject, and with developmental history back to the 50s and 60s. Trying to predict human auditory risk from impulse noise exposure.
So can you quick describe for us what auditory risk units are per the AHAAH?
The ARU is a unit of exposure that the Army's software tool will take when analyzing the waveform, and basically it will assign a number of ARUs to an impulse noise, and that can be used as a basis in the software tool for a prescribed maximum weekly value of warned or unwarned exposures that a person could, with 95% certainty, be expected to safely be exposed to.
Interesting. So it sounds like we can understand not just what the single gunshot noise is now, but how an entire range session could affect our hearing. If you're talking about this new information being able to show us how many gunshots we could safely hear in a day or in a week, is that correct?
Yeah, that's, I believe, the purpose of the AHAAH software tool.
So do you mind if we can go take a look at how this works?
Yeah, let's go over to the B&K Pulse and take a look at the AHAAH software and show people in greater detail how this works. So we've walked over the B&K Pulse system, and we've got PULSE LabShop up. We've taken our 5-round measurement string, and we're going to go ahead and refer to the Excel spreadsheet and grab the muzzle and right ear events that best exemplify the average for that string. And so for this intents and purposes, we're going to call that measurement 4. So we go to the measurement organizer, measurement 4, we expand the time capture analyzer, and what we would be right-clicking on muzzle and saving as a wave file. And we would also save that best exemplifying of the average right ear measurement. Then we're going to walk over to the AHAAH, and we're going to open a waveform. And so we've tested a prototype 22 suppressor. This is right ear. This process is kind of lengthy. It begins with importing a waveform, and then you have to select the piece of relevant time history that you want to analyze, and you have to taper the ends and complete statistics, and then save it as an AHA file. But for the purposes of this demonstration, we've already got the AHA file, and we're going to go ahead and open the AHA waveform right here, and then I'll pull up select segment just for the purposes of graphical display to again isolate the time history that I actually want to display. So you've got 50 milliseconds of data here, and we're going to calibrate, or I'm sorry, we're going to hit statistics. And you see that populates the peak pressure level of 118.100 that matches our A-weighted peak history from our peak testing. It also displays then LAeq and LAeq, which are the average decibel over time of this 50 millisecond history here. And so you've got the 94.116 average decibel of this event, and you've got the 94.644 decibel unweighted average of the event. Then we're going to hit done, analyze for auditory risk units warned, and it will populate the number of exposures with no protector warned, and that's the week average. So if we grab a calculator, we can multiply this 8,813 exposures by 0.4 for a daily allowable average of 3,525 suppressed 22 long rifle gunshots here. I'll show you for a comparison one of the 308 suppressors so you can understand how that differs tremendously. So we'll open the AHAAH waveform for, let's do the M40A5 with PSR 7 right ear. And again, I'll select the segment time history that's relevant to what I had prepped the AHAAH file for, the 50 milliseconds. Hit done, go ahead and populate the statistics, and here we see that we've got a peak pressure level of 132.257 A-weighted decibels at 8.3 milliseconds, so somewhere in the vicinity of this right here would be apparently our peak, or maybe this guy here. And we have the average A-weighted decibel of 114.697, the average unweighted decibel 115.403, and if we go ahead and hit done and analyze for warned, we see we're allowed 95.3 exposures per week. And again, if we take our calculator and multiply 95.3 by 0.4 to get that 200 ARU equivalent value, we've got 38 rounds we could permissibly fire per day, every 24 hours. And so you can see the logic and how this software works. With the rimfire suppressor of a very advanced design, we can shoot approximately 3,500 rounds per day, as long as we're warned. In other words, we're the shooter or we're the observer expecting the shot to happen. And you can see conversely that with one of the louder small arms, a 308 rifle, we're only able to shoot 40 approximate rounds per day. And so you can see how this varies greatly depending on the application. Also very relevant to touch on is that these are warned numbers with no hearing protection worn. Obviously the use of hearing protection, be it something as simple as like AirPods or earplugs or over-the-ear ear protectors, will greatly extend the number of rounds that you can be safely exposed to per day. It'll always be a good idea to protect your hearing as much as possible. But as you can see, this system allows us to increase awareness of what the relative level of safety is. And just for your information, it wouldn't really be safe to fire the 308 rifle 1 round per day unsuppressed. So we've achieved quite a great difference in the sound at the source, where it matters the most, because there might be people at events that aren't wearing ear protection in moments, and obviously they'll be much more protected for those brief exposures with the suppressor. We've obviously done a great deal of work to make those devices as good as we possibly can while keeping them small and light and efficient and desirable to use. So as you can see, the AHAAH software allows us to get that dosing information. It takes into account all of the background noise occurring during the firing event. It provides a risk estimate, and obviously the peak part of this exposure is still a very relevant factor, and it's going to be a driver of research and development for time to come. But this extra information, the average over time, and the exposure levels, as well as the waveform display, I hope will bring some satisfaction to customers.
So thanks for taking the time to talk to us about this. I'm excited to see the upcoming sound testing information that's going to be coming out. I think consumers will really appreciate it too, just seeing a little bit more in-depth information from a bona fide source.
Yeah, we've always definitely been interested in showing people as much information as possible. I think the peak decibel will remain a very important metric for research and development. It's also that easy, like EPA recommended fuel economy or Energy Star simple rating for a product. But this Army Research Lab dosing information is going to give us greater context, hopefully, and I think people are going to be satisfied to see it.